Hi everyone, so in this video we're going to talk about designing a ladder diagram. And the goal here is simply just to build a small little holding circuit on a motor starter. So the motor starter, of course, is what's going to run the motor. When the coil is energized, the coil will suck the contacts down and it'll start our motor. Whether it be single phase or three phase, doesn't really matter, it's going to start our motor. So we want to have a basic holding circuit. So therefore we're going to have a start and stop button. Alright, so I'm going to go ahead and write that down here for us. Start plus stop button. And very simple little concept here, and it really is. And it's a very simple design. But what we're going to do is we're going to go ahead and create our ladder diagram. Now a ladder diagram is always going to have two parallel lines that run on the left side of the paper and the right side of the paper, and they're going to be in the vertical position. And then your ladders themselves are actually going to be the horizontal lines that go all the way across with all the junk on them. We're going to start by drawing our line coming out of our vertical, and we're going to come to a stop push button, just a basic stop push button. And I'm going to go ahead and call that stop 1 normally closed. Okay, this stop button is what's going to totally stop our circuit. It's going to stop the holding part of it, it's going to stop the start button, it's going to totally stop the entire circuit as long as it's pressed. The next part we're going to go to is we're going to go over to our start button. I'm going to go ahead and draw it here real quick. Come out, and I'm going to call it start 1 normally open. Alright, and then we're going to come over here and we're going to draw our motor 1. Now this is the coil on the motor starter. This is not the motor itself. This is the coil on the starter or the contactor that you're using. Now in this case we're going to use a starter because at the end of it I want to use my normally closed contact on the overload 1 for M1 overload. What that's simply saying is when the overload is tripped, it will shut the circuit down just like the stop button does on both ends. So in this case, if I want to stop it, I hit this button and it stops the circuit. In this case, if the motor overloads on the overload contact, it'll trip this out. Okay? Now, the way our circuit's designed right now is we'd have to hold this start button forever in order to keep the coil energized. So we need to develop something that holds this circuit in. So what we're going to do is we're going to parallel around our start button with something. And what we're going to use is a normally open contact off of the coil on the motor starter. Now, depending on the type of motor starter you get, I mean, there's all kinds of them out there. There's everything from Schneider to Telemecanique to Allen Bradley to Omron. I mean, you name it, it's out there. Everything from IEC starters to NEMA rated starters. It all depends on what you want to use. I'm not going to tell you what one we're going to use because in this case I don't really care. And the other cool thing about depending on the starter you use, for instance, I know like some of the IEC starters, you can add blocks on top of the coil, therefore adding all sorts of auxiliary contacts on there. Like I said, it's endless what you want to do. It's up to you, the electrician, the engineer, the designer, whatever, to design your circuit and how you want to do it. But in this case, we need to create a holding circuit that's going to hold it on so I don't have to, or the operator, whoever, doesn't have to stand there and hold the start button forever. So what we're going to do is we're going to use a contact, like I said, off of the coil. It's an auxiliary contact separated next to the coil, on top of the coil, wherever, but it's another contact. It's not the contact that would be T1, T2, T3, or L1, L2, L3 on the starter. It's a separate one. It's going to be marked as an NO, or some of them are 13 and 14, some of them are 23 and 24. It just kind of depends on who's making the contactor or starter. It makes it a starter if you put the overload on there, and like I said, we're using the overload, so it becomes a starter. Along with that, though, is that we've got to use that contact right here, and it has to be a normally open, and we're going to call it M1 auxiliary contact 1. So what's going to happen here is our start is normally closed, so it's closed. We're not pressing the button, but when we press the start button, the coil will energize, and thus closing this contact and holding this circuit on until either the overload is tripped out or somebody presses the stop button and disenergizes and de-energizes the contactor, the coil on the starter. Excuse me. And there you have it, to be honest with you. That's as simple as it gets right there. That's a holding circuit for a motor. Right there, very simple. So now you have designed a ladder diagram for a holding circuit on a motor using a start, stop, push button and the overload contact on the starter. Anyway, thanks for watching.